I have no idea what that means. Work with Joe. May's like, no, I'm not. All right. So when you do math, it generally falls into two categories: algebra or geometry. And the Common Core wants to blend that and show you, like, oh, here's this algebraic concept, and here's where it's used in geometry. Old math said, here's a year of algebra, and then here's the geometry that you should have learned while you were learning the algebra that it goes with next year. So this is what we've been doing with percentages and scale factors and all that, a little bit more focused on the geometric because we have the visual representations to go with it. Done.
What did they do in like ancient Greece before they?
Dude, I wasn't there. I wasn't there. They were inventing it as they went. You ever hear the expression, build a plane while you fly it? So that's the whole point. Like, that's dangerous, right? You're building the plane while you're flying it.
And now that must have been warm.
Mr. Hudson, if you get hit by a bus or a plane on a station in your area,
What's another saying that they used to say back in the old days? Please don't make it more. We already in the olden days.
okay.
Back in my day. Back in my
Back when we used to hunt for skins, we were quiet.
True story, my grandma did used to hunt for squirrels with a rifle. That's how sweet my grandma was.
Killed a squirrel.
My grandma grew up in the Great Depression. My grandma passed away a couple years ago. She was like 90. She was in her mid-90s, so it's okay. She lived a long life. But she grew up in the Great Depression, and back then, if you didn't have food, you went and hunted. So somebody talked about, like, back when you used to get skins or something, like, for real, you can eat squirrel. So she used to, with her dog Bounce, she would go hunt squirrels with her rifle. The dog's name was Bounce. My grandma was like pure old, like, so nice. All right, when we're solving with similar figures, what does it mean when shapes are similar figures? Will?
They're like close to being the same thing, but either like maybe a line is like offset or it's smaller.
Now you're merging two different ideas. So I have to say no because you put too many things together. Same?
They're a similar shape with one change variable.
What do you mean? What do you mean one change? Like I can move a line?
Like, kind of trying to simplify what we were saying was like, what? The word similar means same but not identical. So that's kind of what it's like. It's not the exact same, but it's close.
In your notes, please. Because I only had about 3 hands up, which scares me. Similar figures. Same shape. Different size.
I feel like that's the same.
Yeah, probably.
Same difference is dumb. Please. I do love. Why are you trashing me? Same difference.
So,
Like ice cream and frozen yogurt. They're the same thing.
no,
Just
it's
a little
not.
bit.
We gave up ice cream for Lent. Ice cream and frozen yogurt are not the same.
Wait.
Do not.
Sorry.
Yesterday.
Because it was up.
Fat Tuesday was the last day before Lent. So, when working the geometry, bless you. When working the geometry, you see this shape is the same shape as that, but the one is shrunken down compared to the other, or the one is bigger compared to the other. Depends what direction you go, and you can go either way. This is what we call in mathematics. Anybody know the word? Well, yeah, but
Numbers.
Diagram.
Dilation.
it's I-O-N. You guys scared me, and I turned my O.
Dilation. I got it.
Dilation. A dilation is what the optometrist does to your eyes.
Oh,
When your pupils change size, that's called dilating.
Oh, I know that word. Where's the dilation?
See everything.
I think he got like ripped up or whatever.
What?
He just floated around the room for too long. So my math 2 class made a dilation, dude. I want to remind you guys, the quicker we get through the lesson, the potential more time you have for your homework, which is not happening very well today. So can I, real quickly, see how I go from 9 to 12? Or 3 to 4? Or X to... Oh, well, that won't work very well. So we set up a proportion. And there's a bunch of ways we can do this. A nice, easy way is compare shape to shape in each fraction. So our proportion that we've set up here is comparing small shape to big shape. Gotta be the same side. I cannot compare the 3 up here to the 12 down there. That would be malarkey. I compare the same side. So then to solve the unknown, I grab the unknown that I don't have and compare it to the big, and I set up small to big, small to big. These have to be proportional because that's what dilation tells me. They have a scale factor of proportion. E.
Aren't you adding 1/3 of itself?
So you can think of this in a bunch of different ways. If we broke it down to like a unit rate in a way, saying, well, this adds 3, be really careful because you can't really think about it as addition. But you can say it adds 3 compared to the original 9, and then you say it's adding 1/3 of its original value. I'm down with that, yeah. Because 3, 1/3 of that, right, is 1. It adds 1/3 of its original value. But how do I work it backwards if I'm going to subtract 1/3 of its original value, but I don't know what the original value is? But I don't know what the original value is. And 2 is not 1/3 of 4.
Yeah, that's personal. You know, she's trying to trick me.
And
I don't know if this is what you're doing with the fractions down there. It might be. I have no idea. But couldn't you do
what? I need some screen.
okay, he needs 4 divided by 3 divided by 4? Why 3 divided by 4?
Isn't it? Wasn't that 3 over 4?
Well, yeah, but why?
Because we're going small shape compared to big shape. Small shape compared to big shape.
Yeah, but aren't we going big shape to small shape?
It doesn't matter what way we're looking. This proportion is true. I could make it 4 over 3 and 6 over x. That's
Okay, I like that better.
okay.
Couldn't you just do 4 divided by 3 and then multiply 6? No. No,
Yeah.
or
We could.
Always better.
Always cross multiplication.
I like it.
I'm sorry. I don't like 7th grade body odor, but that's not up to me, is it? So 3 times 6, hang on, then I'll take your question, is the one cross multiplication equal to the other cross multiplication, 4 times x. This gives us 18. This gives us 4x. The answer to x is not 4, my friends and
It's 4 over 18.
Telling you.
no. It's 18 over 4. Alana?
Oh, shoot, sorry. Oh my god.
Oh, okay, what's your question?
So, I was wondering why we were doing 4 over 3 and we just left that as 12%.
So you only need to compare one set that you know both of them, and then one set where you're missing one of them. So let's solve this, then I'm going to show you another thing that we could have done. So this comes out to be anybody.
We already said it 7 times.
Yeah, I said it like a million.
I wasn't there yet. Sorry, doesn't matter if I'm not there yet. Rachel.
Okay, so what I did was I just realized that 4, like half of 4 is 2, and so 2 plus 4 is 6, so it's 150%.
What?
Yeah, it's like
That doesn't
4
work.
times
That's not true.
50%, because then 3.
So I need you to hear me when I tell you, because all you guys have been doing is like fighting for hands up. That's not right. The unknown side that we just solved for is 4.5.
Yeah, I know, but I meant like I multiplied 4 times 150% is 6, and 3 times 150% equals 4.5.
Oh, you're talking about this 4.
Yeah.
Okay, so you're not really looking at this proportionally then? Well, kind of. You're using a way that will work for you but will confuse some people. What Rachel's saying is that I can talk about how the shape relates to itself. So Rachel said the height of my shape is 150% compared to this. So she said 6 compared to 4, which is allowed, but here's why we don't do this. Well, you can, but why we don't encourage it. This is same shape, right? Height compared to top base. That's seriously what we call it. So I have to then height compared to top base. But check out what happens. 18
No, but
4x.
Rachel's strategy is a way easy way. If you take the 12 and the 6, it's divided by 2, so then you 9 divided by 2 equals 4.5.
Yeah.
That was
I was thinking of that earlier. So I was like, that's wrong. That's wrong. But it wasn't.
There are like 19. I'm probably actually like, there's probably actually that many and more. There's like 19 different ways we can look at this, quite legitimately. The big thing is not whether you did it the way we did it. It's do you understand the proportional relationship that exists? So let's look at another. Yeah,
Wait, okay, so about the cross multiplication,
Yeah.
could you simplify like the cross simplifying? and
Yeah, you can
cross
cross reduce.
But when I did that, I think I got
Or sorry, you can't. You can only cross reduce when you're multiplying with fractions.
Oh.
You don't cross like when we're cross multiplying. That's totally different than cross reducing. So if you have fraction times fraction, you can cross reduce that, but fraction equal to fraction you cannot. You can cross multiply. So we just did all this essentially through our conversations with each other. Try this. Now there's less information, right? Less sides, less numbers. That's good for us actually. So we've got 3 situations here. Work through A, B, and C with your partners. B is the only visual. B is the only visual. Letitia. Letitia?
Is that thunder or a truck?
Probably a truck. Actually, I don't know.
It's Simon.
Oh, Scout Skills class. Bring boots.
Ooh, what are you guys doing?
Rescuing people.
So,
Really? Wait, can I be the
so Mr. Hudson, it's the junior class.
Doesn't matter.
Can I be the damn
All that matters is that your one fraction agrees with the other fraction. doesn't lie.
Yeah. Does it have anything to do with the problem?
You can't have two separate values for P and both be right. Again, there's umpteen ways to solve this. Umpteen, very precise number. So, one way that I saw a couple of people doing was to go from 5 to 22 and a half. What would the scale factor there be? 4 and a half. So if you just multiply 7 by 4 and a half, that'll get you there. Another, no, 7, the numerator, because you got to do the same thing in the numerator. Another method, cross multiplication, will give you 5p equals, what is 7 times 22.5?
Oh, I know this. It's 157.5.
Wait, why are you doing? Oh, you're doing cross multiplication.
Now, my question, Rachel, make sure you wrote this down correctly. You had 22.5 down there, right?
What?
You had 22.5 for your denominator? And did you get 157.5?
Yeah.
Okay, just checking. Cause,
Rachel's right, I did the wrong problem.
okay, that's what I'm verifying.
Yeah, me too.
See, I checked with the Annie, she said 24 too, and I was like, wait.
We use our equation solving skills. P equals
31.5.
Yeah.
NB.
You know, it's really
Rachel's strategy is the best on this one.
They know mine is.
Rachel's strategy is the best.
On this one.
I know I'm holding my pen, but if I hit it dead on, which never happens, like, poke, 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 poke. Now, they specifically tell us to use fraction busters, which really, look, we don't have to use it, but I need you guys to remember what that actually is asking you to use. What can destroy a fraction? What can turn a fraction into 1? Thanks for saying it out loud. All because your hand's up doesn't mean you say it out loud. Boom. So as Will said so vocally, reciprocals. Fraction busters, reciprocals, right? So, how would that even apply?
Oh, okay. Couldn't we do like 30 over x equals?
Naya? So you did short side over the long side, right? Because I have short and long, equal to x over 12 is set up incorrectly. So we went 15 over the 30. It's got to be 12 over the x. Because it has to agree. Below.
Wouldn't it be 15 over 12 and 30 over x?
It can be. But then it'd be bigger shape compared to smaller shape. Bigger shape compared to smaller shape.
Yeah, so what's wrong with that?
Nothing's wrong with that. There are umpteen ways to deal with this. Bigger shape, smaller shape, bigger shape, smaller shape. Notice how the 15 is going to multiply by x and the 12 is going to multiply by 30 no matter what way I set it up. I could also go small over big, small over big. I could also go big side compared to small side, big side compared to small side. So, Ian. Oh, you're distracted. Okay. I thought you had a question. Will?
Could you just simplify?
Sure. How's that help? Ian?
So you say umpteen over and over made me think of this. How did they decide to make like all the big numbers like
I'll post the video.
umpteen and stuff like that?
That's not a big number. It's a fake number. Actually, I also have a book there too, red book up there called Big Numbers. It's on my book thing. It's Love the green bins. All right, so the reason they were talking about using fraction busters here, bless you, is that relationship where we have the half or the ones double or things like that. But no matter what route you take to solve this, there's a lot of them. We can end up, I mean, if you cross multiply, you're going to get 360 equals 15x. You divide by 15, you get x is
24.
now C. I heard people arguing like, does this have anything to do with anything?
I didn't say that. I said, does this have anything to do with the problem above?
Oh.
I didn't say anything. And I don't use that voice.
Thank you for correcting me. But some of your classmates were being kind of pouty. 9.
Okay, so I did the 15 over 30 equals, I did it wrong and it x over 12.
Yeah.
But then I simplified the 15 over 30 and got 1 half equals x over 12. And then I cross multiplied them and then I got 24 times x. No.
You made another error, probably. Are you saying you still got the right answer? So you made 2 mistakes.
And then that one mistake fixed
The
it.
one mistake counteracted the other mistake. Yeah.
Good job,
Rachel.
Nadia.
Oh, you're gonna see.
Apple juice. Hit me with it.
Oh, so I did was I put the minutes on the bottom. So
Okay. So you're going to do juice over minutes. A lot of times, I like to jot one of those off to the side of my problem to remind me in my head, because I'm not going to put labels into my proportion, right? But I can reference back to that, oh yeah, juice is on top, minutes is on the bottom.
Alright, so I had 3 over 19
3 over 19.
and then 16 over x. So cross multiplied and so I multiplied 19 by 16 which equals 304.
No and, but okay. And is the decimal point.
And then
Sound like Miss Weller.
I divided
It is.
both of them by 3. Both of them.
Oh, but
And you get,
Wait, why do we multiply?
101, 23, repeat.
or 101 and a third. But sorry, guys, put the
You can
decimal.
write it like that.
Yeah, don't put the decimal and the fraction. Lena?
So, no. Oh. So, you have to, like, do all this dividing and cross multiply. Why don't you just multiply by 16 and the next
You can't. You can't.
This way is just better.
I'm not telling you anything you can't do. So what Mina's arguing is, why don't we just figure out the scale factor one way or the other? And you can. I'm not telling you what you can't do. I'm just giving you more strategies.
Wait, so
Ian.
that's
That was actually a hand.
Yeah, sorry. I put it in a check register. I didn't expect you to call me.
I never call them people.
ever their hand up.
Have you ever, so you know those like $1 million problems?
Is this on topic?
Have you ever considered doing one of those as like?
Ignores
Have you ever made it to a class focusing on what the class is focusing on the
Never.
entire
No.
time?
No.
I thought you were going to say, have you ever made it into a class focusing on that class? But then you said for the whole class, and then I went, no.
You know. I think so.
Wait,
You always look
Ian,
like
here's the problem with your question. Spare time. I work 4 jobs. So, Steve drove 100. Summer school, which I'm already is already starting this year.
Oh my gosh, you're not on.
What? Summer school. You're tutoring rock while summer school.
What is 101 and 1/3?
Oh, the amount of minutes that it would take for that much juice to leak out. Yeah, so it'd be minutes because it was in the denominator. We know it was on minutes. So, but I cleared it. Yeah, 41.
41.333.
Which is only 20 seconds. So, here's one of those other things. A third. We were talking about fractions versus decimal, or well, in Math 7 I was talking about fractions versus decimal. A third cannot be represented by a decimal correctly. Right? 0.3 repeating is still even like an approximation. But a third of an hour or a third of a minute, those things we can express just through label switching. So that's another case where fractions are better. But if you try to use the decimals, it won't come out quite right. Let's look at some more proportions. Steve drove from Portland to Tacoma. It took him 2 hours. It's also a truck. If he continues at the same rate, how long will it take him to drive?
6 hours. 6 hours.
That one's pretty easy, right?
That's easy mental math.
Your brain is making proportions, doing the division, determining the scale factor, and computing
I'm not doing division, I'm doing multiplication.
Yeah, same.
I'm not.
Your brain's doing division to figure out the multiplication.
Really? That's cool.
Your brain first had to compare 390 to 130 and do the division. You had to. That's the only reason you know how to multiply is because you know how to divide. The only reason you know how to divide is because you know how to multiply.
This is confusing to me.
Stop! Stop!
An amusement park charges 50.
So, I'm confuzzled by that statement.
We're gonna move on.
Yeah.
$15 entrance fee, $4 for each ride. How much will it cost to go on 7 rides? Careful. Annie. So if we go back to also what the question's asking, is this proportional? No. Why? You had to explain, like a lot of you keep not doing on your tests. And I'll come back to you. Like, I will bring it back to you.
Because you've already paid a $15 entrance fee. If you only had to pay $4 for each ride, then your ride would equal $0.
So we don't have the 0 points, right? So this is linear. I wrote this on some of your guys' tests. It's linear, but not proportional. It would increase consistently. It increases proportionally, but it doesn't have the 0. It goes in a straight line, but it doesn't start at 0. So Annie calculated her 7 rides and then added on the admission fee.
Thank you.
Armando collected 39 bottle caps. Notice I'm not begging you to write this out or anything. We're just looking at some situations. Armando collected 39 bottle caps in 3 months. Your brain's processing those numbers right now. At this rate, how many will he have in 5 months? Alana, what are you doing? No, just explain. You're fine to grab your calculator, but what are you doing? So 1 month he collected 13. 5 months, quit beating each other up.
And then 13 times 5 is...
Do the 10 times 5, then the 3 times 5. 65, right? Break up the numbers. Are we okay?
Yeah,
Do we need to have like an after school boxing thing so you guys can get it out? We only got a couple minutes left. Hold up. Grocery store sells 3 limes for 99 cents. How much will a dozen limes cost? Will you be patiently waiting? How'd you figure that out?
Basically, a dozen 3 times 4 is 12.
So hold up. You said $4-ish. Why ish?
Because it's 99 cents and it's not exactly $1.
How much is this set missing?
1 cent.
A penny.
So $3.96.
So we'll be missing 4 pennies at the end. So Will did a really good thing. Will said, I can make this $1 for a moment. And then I can make it $4-ish. Then I can correct it. This is only under $1 by a penny. We have 4 sets to make a dozen. So we'll be missing 4 pennies. So $3.96. Maybe you're gonna make a lot of lime.
Yeah.
I mean, how do you think Sonic makes all their lime? And then he took the money times 4, but he had made the money $1, even though it isn't, just to make his life easier. Then he subtracted. Forget it. That's it. I'll see you guys. Hey, be ready. I don't think we're gonna have a mini mastery, but I'll probably show you guys what sort of questions you'll have on the mastery next week. So we're probably doing closure tomorrow. No, this is so easy.
Please. This is so easy. I could do this my own for 5 minutes. Oh my gosh, that's
And then you wouldn't have to show me work, and I like to see work.